Good afternoon, student. Abhay, please raise your hand if I am audible. Abhay. Okay. Thank you. Thank you. Okay. Good afternoon once again to all. Today we will study our next topic, that is Hadoop ecosystem. And in this concept, we will deal with the different framework, or we can say that there are different tools of your Hadoop system. Okay, and there are number of tools that is used in your Hadoop system, and that system is your Hadoop ecosystem, or you can say that Hadoop environment. And these are the Hadoop ecosystem, and we will study in detail what these tools are used for. Okay, and these combination of these all tools make you complete your Hadoop software is complete when your these all tools are there and they work in a collaborative way. Okay. First of all, the tool that is in your Hadoop is HDFS. HDFS stands for your Hadoop Distributed File System. Okay. Why we will use this tool that we will study? In a brief, I will tell you your HDFS is used for your data storing, and HDFS stands for Hadoop Distributed File System, and this tool is used for your data storage. Okay. Then there is a Hive. Hive is also a name given to your open source tool or a software, and this tool is used for your data warehouse. Okay, warehouse is used for your storing the data and also analyzing the data. After storing your data in your HDFS, then we will analyze that data, or we can make a queries on that data. Okay, to make a proper structured data. For that, we will use a tool. That tool is in your Hadoop ecosystem. That tool name is Hive. Okay, and in your Hive, this is a combination of your Hive plus SQL. Okay, means the word we will use in your Hive is your HQL, Hadoop Query Language, and it is a combination of Hive plus SQL. Then there is a next tool that is Pig, and this tool is used for data processing. Okay, first HDFS is used to store your data. Hive is used for analyzing and place a query on that data. Okay, after storing your data, now we will make a query on that, or we will analyze unstructured data so that we can arrange the data in a structured form and store in a memory. Okay, for that we will use a second tool, that is Hive, to analyzing and put a query and place your data in your data warehouse. That is done by your second tool, that is Hive. Then third is your Pig. Now data will be processed. Okay, and that is done by your which tool? The tool name is Pig. Okay, then fourth tool is your Yarn, and Yarn is your map reduce tool. It is previously name was map reduce, but now the name is your Yarn, YARN, yet another resource negotiator. Okay, and this is used to map and reduce your data. Okay, how it will be performed at mapping and reducing, that we will draw a diagram and learn step by step how this will work. Okay, this is also a tool. Then there is a Flume. Flume tool is there. It is a data ingestion tool. Okay, data ingestion that inject the data for storing, for processing. Okay, store in which HDFS. Who will inject that? Flume tool. Okay, Flume, name of the tool that inject the data. Okay, from the environment or a predictive data will be injected with which tool? That name is Flume, and it is stored in your HDFS. After then, Hive can perform their work, then Pig can perform their work, then Yarn will perform their work, and the step by step, each and every component or a system perform their work so that your big data will be arranged and it will be usable for future. Okay, these all components work together and they will analyze your huge volume of data. That is your big data. And the name of your system is Hadoop. And all these tools are collaboratively work parallelly. Uh, Working is there, and they will produce a usable data. Okay, then there is a Aussie tool, then there is a Zookeeper, then there is a Mahout and Ambry. And the word Zookeeper is there because these all tools are named of an animal. Okay, Hadoop name is given from an elephant. Okay, Hive is there. Hive is a combination of your bee and your elephant face. In your Hive, this framework, this is a combination of your bee and your face of an elephant is there. Okay, then there is a pig. Okay, then there is a Flume, and all these are controlled by which tool? That is a Zookeeper. Okay, Zookeeper is your coordination, that is coordinator is this. He will arrange all and every tool, how they will work, and all the job scheduling, all the processing will be maintained by your Zookeeper. Okay, now we will study first of the system or the tool, that is your HDFS, how it will work. I will draw the diagram. Okay, first of all, your tool is HDFS, then there is your pig, Hive, Flume, Mahout, HBase, Ambry, and Zookeeper. These all are the tools that make your ecosystem of Hadoop. Okay. Before that, we will go for Hadoop architecture. Okay, how your Hadoop will store the data, and storing is done by your HDFS, and then how it will be analyze your data with the concept of your yawn. Okay, yawns means to map and reduce. Okay. There are task trackers, there are job trackers. Task tracker will process your data. And job tracker, this will processing will be done by task tracker. Job tracker will perform your job division, job scheduling. Job scheduling is done by your job tracker. Then there are data nodes. Then there are name. This is your Hadoop architecture first, and how they will perform, how your tools will work, that we will study. This data node and name nodes are used in your HDFS. Okay, that is your Hadoop file system. Okay, to store your data, and that is good with the name node with a data. Okay. And this task and your job is done by your okay, or we can say that map ready. Done by your map ready. Okay, this is your task tracker that will process your data. This is your job tracker that will schedule your job, and there is a data node and name node, and these nodes are used in your HDFS. And your job tracker and task tracker are used in your which tool, that is your map ready. How they will work, I will explain. And further, there are task tracker, and these are in your slave nodes. Okay, task tracker are there. There are data nodes, and these are in a multiple node. Okay, task tracker, and there are data nodes. In there are task tracker, there are data. Okay, these are your slaves. These are your slaves. These three. Okay, these are your slaves, and this is your master. Okay, this is your master, and in your master there is the task tracker and job tracker. Okay, all the tasks, or you can say that your data, that is unstructured data, will be there. Okay, and your master slave, oh sorry, master node and in your master node there is task tracker, there is job tracker, and this data will be divided into a blocks. Okay, will be divided into a blocks. All these data, first of all, placed in your main node. Okay. As a name node means I will give this data any name. It can be your B1. Okay. Okay, this is allocated by a name node. Then this data will be stored in your data node as it is without any distribution. Okay, that is stored in your master. Okay, then task tracker and job tracker will perform a map reduce concept. Job tracker will schedule these jobs, these jobs that is stored in your data nodes. Okay, these job tracker will schedule them to different slaves. Okay, job tracker will perform their work. It will schedule these jobs or divide these jobs and store in different slaves. If I will say that this is job 1, it will be stored in your data node 1. Okay, then job 2, job tracker will schedule this job to this node. Means this block is distributed to slave node, and it is stored in a data node of slave. Okay, again third data is there, and job tracker distribute this data. Okay, this data will be distributed by job tracker, and it is distributed to third slave. Okay, and it is stored in a data node. Okay, then there is another data that is 4, and it job tracker will distribute this data to this node, and these are the slave node, and this is the master who will accept the data, and job tracker will distribute data. Okay, and this data will be given some a name, and that name should be stored in your name node. Okay, the name of that block should be stored in your name node, and when it is distributed by job tracker to different slaves, this data node will keep record. Okay, this data node will keep record of each and every slave, which data is distributed to which data node. Okay, this is divided. You will keep the record that this slave 1 have a record of a block 1 and block. Okay, same as it is. This information will be stored in your master block. Again, next block 2 is distributed to slave 2, keep record in your this node. Okay, what size of data is be saved in your data node, and next data should be information should be stored in your data node. And this all information is stored in your master node, but actual data is based in your which node? That is the slave node. And slave nodes have a task tracker and data node. Data node will store the data. Task tracker will process the data. Okay, all these task tracker will process their individual data nodes. Okay, they will process their data nodes. They will perform actual keys. Okay, key values will be performed by these task tracker from where? From these data nodes, because actual data is stored in your data nodes. Task tracker make processing on these data. Okay, valuable data will be accepted. They keep that data record and forward to which? To the master task tracker, and this master task tracker again process that data and arrange that data in a structured form. And here your data is in the form of unstructured form, but it is distributed, and distributed with the concept of your map reduce. Okay, with the concept of your map reduce. And HDFS stores the data. Okay, HDFS stores the data. Each and every information is stored in your data node with the proper name. Okay, this is the complete architecture. Task tracker will process the data. Okay, if there is any data of a huge volume, it will be divided between the slave nodes. These are the slave nodes. And who will divide the data? That is done by your job tracker. Okay, that is done by your job tracker. Any type of data will be came or it can be scheduled by job tracker because this is the master. He will distribute, he is the manager, he will distribute all these data to their slave. Okay, data get distributed. That is your first block, fourth block is placed in your this data node, and that slave's task tracker will process that data. Valuable thing will be accepted. Okay, valuable values or any item that is used for future, it will be accepted and it again forward to the master task tracker. From here, the valuable data will be accepted forward to the task tracker. Again, from here, valuable data will be accepted forward to task tracker of your master will be again process that data. Okay, process that data, store that data for further. HDFS will store your data. Map reduce will map as well as reduce your data. Okay, this is the complete architecture how your data will be stored and processed. Okay, this is the Hadoop architecture. In this manner, your data will be stored and processed. Okay. Now, what is the functionality of your HDFS? All these concepts are performing your HDFS. Now I am talking about HDFS. That is Hadoop Distributed File System. Okay. In this, there is a master node, or you can see that this is your name, and this is your master. And there are further data nodes. Okay, this is your data. And I've said that HDFS is used to store your data. Okay, this is used to store your big data. And this is your master node, and these are your slave nodes. If there is any data in the form of a huge packet, okay, this is your big data. And what does HDFS do? It will distribute this data in different blocks. Okay, blocks. This is your one block, two, third, fourth. Okay, then name node is also called as a metadata because it will keep the record of each and every data. Okay, each and every data that is divided into different blocks. Name node will keep the record that this block is distributed to node 1. Okay, and this is the node 1. You can say that this is the node A. And node A have a block of data that is 1. Then master node or a main node keep track that A is given to, sorry, one block is given to a node A. Then second block is given to node B, and this is your node B. Okay, and there is a second node. And at third node, there is a third node. So third is given to C. Means name node keep record of each and every information which block is given to which node. Okay. And same here, this because this is your master who will keep the record. And this is your actual data where it is stored. Okay, HDFS works in this form. Your name and your basic information will be kept in your name node. Okay, and actual data is stored in your data node. Okay, this is the simple functionality of your HDFS. In a previous diagram, I have completed the complete architecture. Okay, in that your HDFS is also working, and in that your name node and data node combination makes your HDFS. And in name node, you will your Hadoop will store a basic information that where it is distributed the data. It is distributed to which node? Node A. Which block? First block. It will keep the record. Then again, which block is distributed to which node? It will keep the record. Here I have written that second block is given to a B data node. Okay. Likewise, the HDFS keeps the record. And there are two components, that is name node and your data node. And name node is given a name that it is master. Okay, this is your master. And these data nodes are your slaves. Okay, it will distribute, actual data will be stored in your data nodes. And HDFS is used for storing your big data. If I am assuming that this is your huge data, and this will be distributed to different groups. Okay, and information should be kept in your name. Okay, this is your functionality of HDFS. Next, we will study a ER, that is MapReduce. Second environment or your second tool is your. Okay, your MapReduce. John stands for yet another resource negotiator. Okay, in this, here are inputs, any type of input, any type of unstructured data. Okay. Then there is a function that is used, that is map. First of all, we will use a map function. Then we will reduce. Means we are mapping the data. Okay. Then there are further functions that is reduce. That is why the name is given, that is map reduce. And further there is an output. Okay, this is the diagram how your MapReduce will work. Okay, input will be your data. Okay, input will be your data, and that will be distributed to different maps. Okay. If I am saying block 1 is given to map this one map, okay, then second is given to this one, third is given to this one, means your data will be distributed. Okay, and that distribution is done by which tool? That is, we have studied in previous diagram, HDFS. Okay, HDFS will distribute your data according to your name node and data. And there is also a map reduce concept who will schedule your data. Okay, map reduce will schedule your data. Their main function is job scheduling. Okay, if input is there, if there is any data, it will schedule that data to different maps. Okay, distribute. It will distribute to this map, then second map, then third map. Okay, then there will be a conversion. Okay, what conversion is there? That set of data converted into tuples. Tuples are your key values. Okay, your set of data is there, that is your input. Okay, map reduce. This will be distributed to different maps. Okay, your task will be, your job will be distributed to different maps, and that is the functionality of your job map view. It is distributed to different maps, and in this map will convert your set of data into tuples. Okay, and tuples are your key values. Okay, then these tuples are recorded with the key 1, with the key 2, with the key 3, with the key 4, with the key 5. And this is your converted data from different maps. Okay, we will assume that this is key 1, key 2, key 3, key 4, and key 5 from map 1. Okay, and same way there is a map 2 data. It will be another key. Then map 3 is there, and further these data will be reduced, and from these key values the actual accepted keys are there, the values that are further used. Okay, it will be reduced. Okay, if I say that I only use key value 2, 4 and 6, that is only useful for me. Okay, then key 1, key 3 and key 5 are not usable. Then this accepted keys are performed by your reduce function. Okay, these will be accepted, and this will be further your output. Okay, like this method your job map reduce will be work. Input is your set of data. Okay, then the data will be distributed. Okay, and that is done by your which tool? That is done by your job tracker. Okay, we are studying our architecture. In your map reduce, there are two components, that is job tracker and task tracker. Okay. Job tracker will distribute your data to different name nodes, and that is distributed, okay, to different name nodes. And these name nodes or your name node having data in a distributed manner. Okay, and in that name node there is a processing, that is map. Map function is used, and in the same way, one different data node have a map function, and another data node have a map function, and they will perform their map function. And what is the functionality of your map function is your data will be converted into tuples. Okay, it means your key values will be generated according to these functions. Okay, Again, these key value will be reduced. Only that values will be accepted that is usable for us. Okay, then they will reduce that key value. And that value that is usable for us, that will be our output. That is the function of your job. Yet another resource negotiator, and the name of your complete job is your job map. It will map and then reduce your job or your complete data. That data that is usable, that will be accepted, and the data that is not further used, it will be rejected. This is the functionality of your second tool, that is log. HDFS is used to store. This is used for your distributed processing and parallel processing. Okay, your MapReduce will be used for your distributed processing. Distributing is there, and also processing is there, and your values, key values will be accepted. That is your process. Okay, this is the functionality of your YOR. Then next component or next tool that is used in your Hadoop ecosystem is your PIG. Okay. And this is used for your data processing. This is your data processing tool. Okay. How it works? Further, there are in your PIG there is a language. Language is used. This is a high level language. Okay. Your high level language is used. That language is your PIG language. Okay, PIG Latin its name is, and it is a scripting language. Scripting language. PIG is a tool, and it is used for data processing. Okay, data will be stored. Okay, now you want to process your data, and for that your PIG tool is used, and in your PIG there is a high level language that is used, and the language name is your PIG Latin, the same way as your Python you are using. Okay, it is somewhat concept of your Python is in your PIG Latin. Okay, this is also your scripting language, and this also requires PIG tool also requires your JRE. Okay, JRE stand for Java Runtime Environment. I have said that your Hadoop is completely based on your Java, JDK. So that for your PIG, there should be a JRE. Execute all these data processing. We should have a JRE in our system. Okay. To execute your Java scripting language, PIG also have an Apache PIG engine. Okay. To execute your scripting language, there should be a PIG Apache engine. Okay. For your Python, there is a compiler. The same way for your scripting language, that is in the form of your high-level language that is executed by your Apache PIG. Okay. And how it will work now that I will be explaining. In your PIG, there are UDF, that is undefined function, and LFS is your local file system. I will draw the diagram first. There is a pig script. Then there is the pig Latin. That is a compiler. Then there is your input file in HDFS. Then there is execution of map reduce. This is your output. Okay, this is your complete structure, how your thing will work. Okay, it is your tool. First of all, you have a user-defined function in your local file system. In your program, you have a user-defined function. Okay, if you are using your Python, there are user-defined function, that is your input, that is user-defined function you will use. And first step, that is it should have a pig script. Okay, this is your pig script. That this user-defined function will be converted to your pig script. Okay, and your output of your pig script means script values are collected from your user-defined function. This is your first step. Okay. From a user-defined function of your local file system, the pig scripts are accepted. Okay, or collect the values or that is related to your pig script. Then it will given to your pig Latin compiler. Okay. Pig Latin compiler. This is your second step. That is to give the pig script values to the pig Latin compiler, and there is also input from your input file in HDL. Okay, the files that are stored in your Hadoop distributed file system. From there, your unstructured file or your data will be given to a pig Latin as an input, as well as from the pig script will be given an input to the pig Latin. The combination of both will be compiled by the pig Latin, and from this pig Latin, after compilation, it will execute a map reduce. Okay, what is the function of map reduce is that we have studied in a previous diagram. Map reduce will convert your data into a tuples, into your key values. Okay, then again it will reduce your data. Okay, then there is the execution of map reduce. Okay, that's why your pig script is there. Then after pig script, there is a compiler, and in your compiler, your script as well as your data that is stored in your HDFS. There is a combination of three tools: your HDFS tool, your pig tool, and your MapReduce is working together. Okay, pig script will be compiled, data from HDFS will be accepted, both will combine and produce some output, and that output is your execution of MapReduce. And after there is a data, after execution, there is a data, and that data again will be perform a function of MapReduce. Okay, on tools data. MapReduce function will be performed using a tool that is MapReduce. Okay, after that, there is a last output That output is your file stored in your again HDFS. After processing your complete data, accepting the scripts, compiling that script with your data, makes a execution, and this is output as a map reduce. Again, there is a map reduce function will be executed. Then after that, the output from the map reduce is your output. Okay, in this manner, your data will be scripted, combined with your actual data that is stored in your HDFS. Okay, and after compiling that, your execution will be there. That is your output, and that output will be there. And on that, again, map reduce function will be executed. And after that, there is a complete output that is your proper data, that is your actual data that you needed. HDFS is used for storing your data. In your HDFS, there is a structured data, there is unstructured data, and there is also your semi-structured data. And this is the technique on your all computation. Okay, to store your data unstructured or structured. Okay, I will explain it again. Actually, your pig is used for your data processing. Okay, there is a data processing is going on. First of all, what type of data? This is your user-defined function. You are written any type of function in your programming language. Okay, I have said that I have written a user-defined function in my Python. Okay, and LF stands for local file system. Means that there is any program in my file system, that is in my hard disk. If I am accepting that data, it is a first input. Okay, first input. After that, a pig script will be there, and that pig script will be performed by your which tool? Pig tool. Okay, because this is the ecosystem in your Hadoop. Pig tool will perform a pig script, means from these programs, the value that is in the form of scripting language, it will be accepted by a pig script. Okay, only that values or that instruction will be accepted. That is a pig script. Okay, the other values or instruction will be rejected. Only pig script will be accepted. That is the first step. After that, there are only pig scripts there. These pig scripts will be compiled by your pig Latin compiler. But for scripts, there is also a data, and your data will be claimed from your HDFS. That data will be stored in your Hadoop distributed file system. And we have studied that in your Hadoop file system, that diagram that I have done, there are master and slave. Master is your name node, and slave is your data nodes. Okay, all your actual data is stored in your data nodes. Okay, but information is kept in your name that is used to storing the data. HDFS have a data. This have a pig script. Okay, the combination of from pig script data came to your in pig Latin compiler, and actual data that is stored in your HDFS came from your HDFS to pig compiler. Okay, and from script came to your compiler. With the both the combination, compiler will perform their work. Okay, from data here and script from your programming language, and it will compile that and perform your output, that is your map reduce. Okay, means these are the values. Okay, then on that there is again a function that will be executed, that is map function, and from this there is a analysis. Okay, this map function will be executed. Then after mapping, then again there is a reduce function will be executed that we have done in your tool. Okay, map reduce will be executed. After that, after your this map reduce concept will be executed, After this, the output that is generated, that is your actual output file. Okay, these are the valuable values. Structured data is there. Okay, that will be stored in this. Hope you will understand this. Main three tools. Okay, pig. Then before that we have studied yawn, and before that we have studied HTF. Okay. Then there is another tool that is used Flume, and I told that Flume is used to inject the data. Inject the data in your HDFS. Flume is used to ingestion it is a data ingestion tool in HDFS. Okay, this Flume, it is a data ingestion tool. Data is injected. Any type of data in any form, it is structured, it is unstructured, it is semi-structured or quasi-structured. It will be injected in your storage, and that storage is your Hadoop distributed file system. And from this distributed file system, then data will be analyzed. Okay, analyzed by which tool? That is your. Okay, after analyzing, processing will be done. Processing by which tool? That is big tool. Okay, after processing, all the data will be stored again in the form of structured as well as in the form of unstructured, and that is in your HDFS. Okay, this is the step how your Hadoop will work. Then there is another, that is Hive. I have told that this is a combination of two concepts, that is Hadoop as well as your SQL, or I can say that it is a Hive plus SQL that creates your HQL. Okay. Hive plus SQL, and the name is your Hadoop query language. Okay. And it is also open source data warehouse system. And these are the work as your SQL work, that is structured. Okay. And feature of Hive is it is scalable. Okay. Feature of this Hive tool is it is scalable. Okay. Then there is HBase. Next tool is your HBase. That is Hadoop database. Okay, in your Hadoop database, it is designed to provide a quick random access to a huge amount of data. We can assess any type of data randomly. Okay, in your HBase concept, Hadoop database concept. In this, we can assess data randomly from a huge volume of columns. Okay. Then there is Mahout. MAHOUT. And the name given to amount according to your learning machine learning concept is added in this. Okay, machine learning libraries are used in your Hadoop. Okay, machine learning libraries are used in your Hadoop. Okay, that is why a name given to it Mahout. That is machine learning libraries are added in this for your predictive analysis. For predictive analysis. Okay, further we will study in detail what the functionalities of Mahouts are. The main are machine learning concept is added in this. Okay, for what? For your predictive analysis. Okay. Then next is your scoop. SQP. Scoop. Okay. And this is also a framework. The main functionality of this framework is to import structured data from RDBMS to your HDFS. This is your main functionality of your scoop base. Okay, scoop is like your ice cream scoop. Okay, that is why in these big way. That is scoop. Okay, this is the structure of your scoop ice cream scoop is that is why I'm giving you that is a scoop like structure is there. And what is the main functionality is import structured data from your relational database to your HDF. It will import your structured data. Structured data from your RDBMS to your HDFS. And second functionality is vice versa. It will export structured data from HDFS to your RDBMS. Okay, is from picking from one location, okay, and placing to another location. Okay, that is the work of in your Hadoop. Okay, what is the import structured data from where? From your RDBMS, that is relational database to your Hadoop file. Hadoop is okay. Then next function is export. First is import from where? RDBMS to HDFS. Export from structured data from HDFS to your RDBMS. That is the report. And last is your zookeeper. Okay, the coordinator. Coordinator is your zookeeper who will control your complete ecosystem. Okay, control your complete ecosystem. That each and every tool are working correctly or in a collaborative manner or not. Okay, that is checked by your zookeeper. The name given is okay, that's all your tools are in your Hadoop ecosystem. And now we will study in more detail their functionalities, their advantages. Okay. This is your complete ecosystem. Is there is Flume, there is Scoop, there is a symbol of Scoop is, watch the cursor, that is a Scoop is like this. Okay, there is a Scoop is made, that is for data exchange. Okay, I have told that there is import and export. Scoop is used for your data exchange. Flume is used for your log collectors. Okay, ingestion. I have told that data ingestion is performed by your Flume. Zookeeper is your coordination. Okay, the man is there who will control your zoo. Then Aussie is there. Workflow will be mentioned there. Pig scripting. Okay, Pig Latin language is used in your Pig, and this is used for processing. Okay, then the Mahout is there. Mahout is a concept of machine learning is added in this. Machine learning libraries. R connector. This is used for your static values. Okay. Then Hive. Hive is a combination of your HQL. Okay, means Hive plus SQL. HBase is a columnar store. Data stored in the form of columns. Okay, huge data store. Then there is a Yarn. Yarn is for your distributed processing framework. Your MapReduce. Full name is your MapReduce. Okay. Then there is a HDFS, that is Hadoop distributed file. Okay, and last is your Ambry, that is the provisioning and managing and monitoring. Ambry will your manage and monitor your complete Hadoop cluster. Okay, this is this tool is left. Ambry is used for your managing and monitoring your Hadoop cluster. Now, in detail, first of all, HDFS stands for Hadoop Distributed File System. It is used for managing big data sets with a high volume, velocity, and variety. Okay, it is used for storing. Okay, last point is there. HDFS is well known for its big storage, big data store. Okay, and big data sets will be in the form of your volume, velocity, and variety. These are the 3 V's, and we have studied 5 V's. Okay, nowadays there are 5 V's. HDFS implements master slave architecture. Okay, HDFS implements master slave. Master is your name node and data nodes are your slaves. And the next point is there, master is your name node and slave is your data node. Okay. Next features of your HDFS is it is scalable, reliable, and community hardware is there. Okay. Your product can be scalable if there is a huge volume of data, it will be increasing day by day, it can be scalable. It is a reliable also. Okay. Next is Hive. Apache Hive is another high-level query language. Okay, high-level query language. I told that Hive is the combination of your Hive plus SQL and makes your HQL. Okay, that is a Hadoop, or you can say that high-level query language, and data warehouse infrastructure built on top of your Hadoop. Data warehouse infrastructure built on top of a Hadoop. Okay, this is your Hive built on the top of your Hadoop. It provides data summarization, queries, and analysis. Okay, what does your Hive will perform? It will summarize. It will perform a query on that, and you can also analyze. Okay, you can also analyze your data. Next, it was initially developed by a Yahoo and later made open source. Okay, Hive is developed by Yahoo. The same way your Hadoop is developed. Hadoop is initially developed by your Yahoo, then it is denoted to Apache. Okay, the same way it is initially developed by Yahoo and later on it is made an open source. It has an SQL-like query language called your HQL. HQL is your high query language. Okay. It provides partitioning and bucketing for faster data process. And Hive is used for your querying and analyzing. Okay, querying and analyzing, and this will make your processing faster. Okay, and this is your second tool, that is Hive. Third tool is Pig. Apache Pig, and this is also a product of Apache, is a high level language built on top of your MapReduce. Okay, built on the top of your MapReduce. It is used for analyzing large data set with a simple data analysis program. Okay, it is used for your analyzing your large data sets. Pig is also known as data flow language because in this Pig Latin language is used, and for that we are using a Pig scripts. Okay, and Pig Latin is your compiler. It is very well integrated with Python. Okay, this your Pig Latin is integrated with the concept of Python. That is why it is a scripting language. Okay. It was initially developed by Yahoo and later made an open source. And Pig is used for processing your data. Okay, this is the main point. Pig tool is used for processing your data, processing as a Pig script and your data, and that is compiled by your Pig Latin compiler. And after that, the output that is produced, that is again executed by your MapReduce. Okay, and further the output that is produced by your output MapReduce is your actual output, that is valuable data. Then next tool is Yarn. Yarn stand for yet another resource negotiator. It is also called a MapReduce, a version second, and the short form is MRV2. Okay, the two major functionalities of job tracker. I have told that in your MapReduce there are two components. First is job tracker and second is your task tracker. Job tracker will schedule your jobs, divide your jobs, and keep the resource management. Okay, that is a function. I have drawn a diagram on board, and there is a two component of MapReduce, that is job tracker and task tracker. Okay, the two major functionalities of job tracker is, now I am talking about job tracker, and those two functionality are resource management and job scheduling. Okay, job scheduling as well as monitoring on how much task is completed, what data node had completed the task and not. Okay, if there is any data node that is in a error or in a fault condition, then it will go for a next job scheduling to next data node. That is all managed by a job tracker. And there are two components in your MapReduce, job tracker and your task tracker. Job tracker will schedule your jobs and task tracker will process your jobs or your tasks. Okay. Further in Yarn, after MapReduce, the more functionalities added, and new version that is made is MapReduce version 2. And in your MapReduce, there is a version 1. Okay. In Yarn is also a component of your MapReduce. The daemons are renamed. Okay, the daemons are renamed, and the names that is given is resource manager, node manager, and application master. Okay, the name given to the or your functionality provided to a job tracker is resource manager. Your job tracker is your resource manager, node manager, and your application master. Okay, in a product that is a your MapReduce. If we are talking a simple MapReduce, and they have only two functionalities, that is resource manager and scheduling and monitoring. Okay, then there is a Flume. Next tool is Flume. It is an open source tool for collecting, aggregating, moving a huge amount of data from an external web server to a central store. Okay, means injecting. Data is injecting to HDFS. That is the line I have written on board. That Flume is used for data injection in HDFS. And here that line is explaining that it is an open source tool for collecting. It will collect, aggregate, and move a huge amount of data into your HDFS. Okay. It is highly available and a reliable service which have a tunnelable recovery mechanism. Okay, it can be recovered in future. A company has millions of services that are running on a multiple servers producing lots of loads. Okay, example is there means there are number of companies like a Google, they are producing a million of data in a 60 second. Million of data is producing by a Google, and that data is distributed on a different servers or on a different data nodes. And from that data nodes, they will process that data, that proper location. Different servers are there. Their own server, their own task tracker will process the data and again submit that data to the master node. And that master node also have a job tracker and a task tracker. Again, that data from a data node or a task tracker of a data node will be placed in your master task tracker. Again, master task tracker will analyze data from these data. Okay, that is all done in your flow. In order to gain insight and understand customer behavior, they need to analyze these logs all together. Okay, to understand customer behaviors, because all the data is from the customer sides. Okay, and from there it will be assume, understand from the customer behavior what customer needs. Like in your big bazaar, okay, big bazaar or your Walmart, the maximum purchase from the customer, that item will be selected by the servers or by the task tracker, and that data will be further provided to your master task tracker. They will analyze that what customer actual wants. That is the point here. It is the in order to gain insight and the understanding customer behavior, what customer wants, that demand will be fulfilled frequently, and that all is done by your tool, that is Flume. Last point is, in order to process logs, a company requires an extensible, scalable, and a reliable distributed data collection service, which must be capable of performing a flow of unstructured data. Okay, there is a flow of unstructured data that is should be completely fulfilled, injected to your HDFS. Then there is after HDFS, there is a distribution of data from name node to data node, and there is again a functionality is performed by a map reduce. That is mapping function is there, reduce function will be performed. Then after that, there is a processing that is done by your PID tool. Okay, and injection of your complete unstructured data is performed by your Flume tool. Next, Scoop. It is a tool designed for efficiently transferring block data between Apache Hadoop and external data. And I have told that Scoop is used for your importing your structured data from your RDBMS to your HDFS, and that is your Hadoop will perform. Okay. Next, Scoop is used to import data from your external data source. External data source is your RDBMS into your HDFS, that is Hadoop files. That is the point. Scoop is used to import from your external data store, and external data store is your RDBMS, relational database, into your HDFS. And same, there is export your structured data from HDFS to your RDBMS. That is the functionality of your Scoop tool. And component that is used is Hive and HBase. Data is stored in your HBase, and data query language that is performed on that data will be by your Hive. Okay, there is a both these components will perform a work and they will store the data in your HBase, and all these import and export will done by your school. Okay. Then OZ is there. OZ is a workflow scheduler system to manage Apache Hadoop job. This is the workflow schedule. OZ tool will flow your data from one place to another. Like if there is a data in a HBase, I will accept that data, perform their queries on that, and again store that data in your HBase or in your HDFS. And all these workflow will be managed by your Aussie tool. Okay, Aussie workflow jobs are directed acyclic graphs. Okay, it will work as a directed acyclic graph. Aussie coordinator jobs are recurrent Aussie workflow jobs triggered by your time. Okay, there is a proper schedulings are there. If there is a job scheduling, time should be maintained. Okay, like operating system, we have studied that there is a time sharing between your processes. Okay, in your operating system, we have studied that there are different algorithms are there. There are job scheduling, there is a process scheduling, there is a time sharing, there is a time quantum round dropping concept. In the same way, if there are a job scheduling is done and workflow are there, then according to that, your time should be triggered. Means that this job will take this much time to execute. Okay, and that all will be maintained by your Aussie tool. Time scheduling, triggering concept. When your page will be triggered on your website. Okay, and when it will be rejected from the website, that is triggering concept is there. Okay, that is according to the time scheduling is there. Aussie is integrated with the rest of the Hadoop stack, supporting several type of Hadoop job. Okay, Aussie is integrated with all your further tools. Okay, this Aussie is integrated with the like your MapReduce. Okay, with your peg, with your Hive, with your scoop, it will integrate it and work together. Okay. Aussie is a scalable, reliable, and extensible. This is the feature of your Aussie. It is scalable, reliable, and extensible according to your environment. Okay. Next is your Zookeeper. Zookeeper is centralized service. Okay, who will coordinate, who will control your complete Hadoop ecosystem, and that all by done by your Zookeeper. Okay, like a watchman. Okay, the name given to a tool is Zookeeper. It will perform all the coordination, all your configurations, naming, okay, synchronization. These all are checked by your Zookeeper. Feature is serializability, atomicity, reliability, and your APIs are. That is application program interfaces. All these are managed by your. Okay, then there is next Mahout. Apache Mahout is a scalable machine learning library designed for building predictive analytics. Okay, in this Mahout, there is a concept of machine learning libraries, and if there is a machine learning means we can perform any type of analysis. It can be predictive, it can be distributed if there is a tool that is a Mahout, because Mahout is made up of machine learning libraries. Okay. Mahout now has implementation as a Apache Spark for a faster in-memory computing. Okay, the concept that is added to it, the name now it is Apache Spark. Spark. Okay, Spark for faster in-memory computing. The last is your Ambry. Ambry is designed to make Hadoop management simpler. Okay, this will make your management simple. Okay, and it also monitor your Hadoop cluster. Managing, monitoring, all should be performed by your tool, that is ML. Okay, these are your tools that are in your Hadoop ecosystem. They will work collaboratively together. They will perform their task, and their output will be distributed or provided to the next tool. So they will perform their own task and produce a valuable data. Okay, all these tools have their different functionalities. Now, if you have any question, you can ask. This is the complete tool. Okay, but in our syllabus, we will further study main tools that we will study is PIG, your HDFS. Okay, if you have any question, you can raise your hand or you can message me. If it is clear, you can also message that it is clear.